Hello, how are you, dear students? Our lesson today talking about Cartesian product. First of all, let me remind you with the order pair. The order pair, like for example A comma B, this is order pair, and the first component here, A represented the first projection, B represented the second projection. And if we said that there are two order pairs are equal, then the first projection A equal the first projection X, first equal first, and the second equal second, then A equal X and B equal Y. And here if we reverse the two order pairs, the two components of the two order pairs, then they are not equal, because here they have different locations. A, B not the same as B, A. And here you will find that the order pair not the same as the set A, B. There are two elements in the set, but here this is order pair formed from two axes X and Y. To prove that the two order pairs, they are not the same, they are different, let's graph each one. To graph 2, 3, then you will move to the right 2 units and you will move up 3 units, but the order pair 3, 2, you will move to the right 3 units and you will move on y-axis up 2 units. Then they have different locations, different positions. Here the first projection represent x-axis and the second projection, as we said, represent y-axis. Let's solve some questions about the equality of two ordered pairs. Here, as we said, the two ordered pairs, if they are equal, then the first projection x power 2 minus 1 equal the first projection 48. Let's solve this equation. By moving negative 1 to the other side, then x squared equal 49. To find the value of x, then we need to get the square root, but remember that you have to find the two roots, positive and negative. Square root of 49, because this is the equation of x power 2, then the two answers works. Then here we have two solutions of the variable x. To find the second projection, here we said y cubed equal 8, the second equal second. Then to find the value of y, then we need to find the power 3 of both sides, then y equal 8 power 3, that equal 512. Let's solve one more question. Two order pairs, they are equal, then the first equal first, y power 5 equal 32. Then to find the value of y, we need to find the fifth root of 32, that equal 2. Let's solve the second projection x plus y equal 2. Since we solved in the previous step that y its value is 2, then we can make substitution here, then x plus 2 equal 2. By solving this equation, you will get x equal 0. One more question, x minus 1, this equal the first in the other order pair, 2, then x minus 1 equal 2, then x equal 3. And the second projection y minus 2 equal 3, then y equal 5. Let's explain another part of our lesson, how to find the Cartesian product of two finite sets, two limited elements of each set, like set x and set y. Okay. Then to find the cross of two sets like these two sets x and y, you will find the answer formed from or consist of some elements like order pairs. And all the order pairs, always the first projection belongs to the first set, and the second projection belongs to the second set. Okay. To make it more clear, let's solve this question. Here, if we have two sets like x equal two elements 1 and 2, y equal 3 elements, set of 3 elements 5, 7 and 8, let's find x cross y. To find the x cross y, then we need to participate the first element to make pairing first element here 1 with all the elements of y. That means 1, 5, 1, 7, then 1, 8. After that, the second projection 2 always will make pairing with all elements of y to make to make 2, to say 2 5, then 2 7, 2 8. Then x cross y, we got the elements or the order pairs 1 5, 1 7, 1 8, 2 5, 2 7, and 2 8. And as we said here in the definition of x cross y, that all the first projection in all elements, as you see, is first projection or first element of x, or belongs to x. Okay, and the second projection, of all the order pairs here, you will find belong to the set of y, like as you see, 1 1 1 2 2 2. This is the first or the elements belongs to x, and the other projections 5 7 and 8, all of them, the second projection belongs to the other set y. Let's see how to graph, or how to find the answer graphically after finding the answer algebraically by writing the order pairs. Let's graph the order pairs using two different ways. The first way is called arrow diagram, and the other one Cartesian diagram. Arrow diagram, we will make two rectangles like this. For finding the arrow diagram, to make the arrow diagram of these two sets, x from x to y, x cross y. And to make the Cartesian diagram, we will draw rectangle for the first set x and rectangle for the second set y. Okay, and you will draw vertically lines like this from each element, vertical line here and vertical line here, and horizontal from the other elements 5 7 and 8. And you will represent like your graph. You will represent 1 with 5, you will put dot here, and you will write the order pair. 1 with 7, then 1 with 8, and the other elements 2 with 5, 2 with 7, 2 with 8. And this the graphing of the cross x and y, x cross y, arrow diagram and Cartesian diagram. Okay, okay, let's solve the other question like this one. If x equal 1 2 and y equal 5 7 8, let's find y cross x. In the previous slide we solved x cross y, but right now y cross x. Let's see if both of them are equal or not. Is it equal? Y cross x is the same as x cross y. Let's see if they are equal or not. Y cross x, then we will start from the elements of y to make pairing with the elements of x. Then we will get 5 1, then 5 2, 7 1, 7 2, then 8 1, 8 2. Then this is y cross x, completely different from x cross y. They are different, they are not the same, because we got different order pairs. Then x cross y not equal y cross x. Okay, because the order pairs, they are different. 1 comma 5 not the same as 5 1. But we can say that x cross y equal y cross x if x equal y, or one of the two sets equal phi, not an empty set or doesn't have any elements, because x cross phi equal phi cross x equal phi. Okay, let's solve one more question. If x equal 2 3 4 and y equal 1 5, find each of the following. How to find x cross y? Then x cross y means we will make pairing starting with the elements of x first, then 2 participate with 1 2 1, then 2 participate with 5 2 5, then 3 1 3 5. After that 4 1 4 5 to get the elements or the ordered pairs of x cross y. To find y cross x, then we will start with the elements of y first as first projections, then 1 2, then 1 3, 1 4, after that 5 2, 5 3, 5 4 as the first projection. X power 2 means x times itself, or x cross x. If we have elements of x like 2 3 4 and the same set cross with itself 2 3 4, then we will make 2 2, then 2 3, 2 4, after that 3 2, 3 3, 3 4, and 4 2, 4 3, and 4 4. What about the other example, n of x cross y? What does it mean? N here represents the number of elements. N asking you about the number of elements, how many ordered pairs of x cross y. X cross y, as you see, we have 1 2 3 4 5 6 elements. Then the answer of this one, 6 elements. What about if I asked you to get the number of elements of y cross x? You will get the same number of elements, okay? Because here x cross y or y cross x, you will get the same number of ordered pairs, not the same ordered pairs, but I'm talking about the number of ordered pairs. You can get the answer of this one using this way without writing the order pairs. To find the number of this cross, just look at the number of elements in x. Here we have 3 elements, and the number of elements of y, we have 2 elements. Then the cross 2 times 3 equal 6 elements, okay? Then if number of elements of x is 3 elements and the number of elements of y 2 elements, then the cross means 2 times 3 equals 6 elements, okay? And as we said, the order pair, if the order pair that you found from the x cross y order pair, like for example 3, 5 belongs to the cross of x and y, then always the first projection 3 belongs to the first set x, and the second projection 5 always belongs to the second set y, okay? And we solved a question like this: x equal 1 2, then x cross x, or x power 2 means 1 1 1 2, then 2 1 2 2. Then we have 4 order pairs of this cross. Let's solve these questions. If we have 2 sets like 2 4 and 3 2 to make the cross of these 2 sets, as we said, then the first element here 2 will participate with 3, then 2 3, 2 2, after that 4 3, then 4 2. The cross of these 2 sets 3 and 5, we will get only one order pair, 3 5. And remember guys, to write the order pairs you have to make the curly bracket of the set. Don't write only order pair 3 5, this is wrong. You have to create the curly bracket of the set, okay? Because this is product or cross of 2 sets, then the answer is supposed to be also as a set, like this. If the number of elements of x equal 2 elements and number of elements of y equal 4, then the number of elements of x cross y equal 8. 2 times 4. If the number of elements of x cross y 6 elements, and if you know that number of elements of x 3 elements, then what about the number of elements of y? Yes, equal 2, because 6 divide 2 you will get 3. 6 divide 3 you will get 2 elements of y. If the number of elements of x equal 4, then number of elements of x power 2. X power 2 means x times x cross x, means 4 times 4 you will get 16 ordered pairs or 16 elements. Let's find A cross B. If you know that A equal the elements 1, 2, 3 and B equal the elements 2, 4, 6, then let's find A cross B. Using the same way, 1 will participate with all the elements of B, 2 will participate with all the elements of B, 3 will participate with all elements of B to get 9 order pairs like this. 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6, and so on. Using the same way, we will solve B cross C. Try to solve it by yourself, please. You can pause the video and try to solve it by yourself to find B cross C. Okay? Then the answer of B cross C also 9 elements. Okay, like this. Let's find A intersection B. Let me remind you with the intersection of two sets. Intersection of two sets means the common elements of A and B. As you see, the common elements of A and B is only element 2, is 2. B difference C means the elements in B not exist in C. The elements on B, on set B, only 2 and 6 not exist in the element C. Okay, then B difference C, the elements in B not exist in C is 2 and 6. Let's find the cross of these two sets. Okay, then as we said, 2 will participate with all elements of the second set. That means 2, 2, then 2, 6. Let's explain another idea of our lesson. Here mention the quadrant of the axis on which each of the following points lies on the perpendicular square net of the Cartesian product A r times r. This is the second part of our lesson, Cartesian product of two infinite sets. As you know, real numbers, this is infinite set. Then to locate each point of those, we need to make the graph, x-axis and y-axis, the perpendicular square net. This is the graph, x-axis and y-axis. To locate each point of those, here we know that the first represent x-axis and the second represent y-axis. Then to represent the point A, then we will move to the right 2 units, then move down 1 unit to represent point A. To represent or to locate point B, then we will move on x-axis to the left 4 units and we will move up 1 unit. And to represent point C by the same way, 1 unit to the right, 3 units up. Point D, negative 2 means 2 units to the left and 2 units down to represent point D. But to represent point E, focus on this, guys. Point E here 3.5 units to the right. Okay, but 0 means y equal 0. That means we didn't move up or down. Then point E locating on x-axis. Okay, point P, we will not move to the right or to the left because x here is 0, but we will move down 2 units, 2.5 units down. Then point P lying on y-axis. Okay, he asking us how to find or mention which point locating or mention the quadrant that each point locate. You will find here that starting from here, this represent the first quadrant. Here we have 4 quadrants. Okay, starting from this one, this is the first quadrant by moving anti-clockwise. Then this is the second quadrant, and this one third quadrant, and this is the fourth quadrant. Then you have to mention each point locating in which quadrant, like point A, as you see, in the fourth quadrant, point B locating on the second quadrant, point C in the first quadrant, but point D in the third quadrant. What about the other 2 points E and P? They are not locating in any quadrant, but locating on the x or the axis. E on x-axis and P on y-axis. Okay, By the way, let me tell you something about the points, how to figure out in which quadrant each point locating. Okay, without graphing any point, you can figure out in which quadrant. In the first quadrant, you will see that all the points locating in the first quadrant, both of them x and y, both of them positives. Okay, then any point like point C, for example, 1, 3, this locating in the first quadrant because x and y, both of them positives. What about the points that lying on the second quadrant? You will find x is negative but y positive. Okay, third quadrant, both of them x and y, both of them negatives. Fourth quadrant, you will find x positive and y is negative. This way to figure out in which quadrant the point lying. Okay, then you can use this way. That was our lesson. I hope it was clear. If you please to watch the video one more time and try to solve the questions, and I hope that everything was clear. Thank you for listening and have a nice day.